All right, ladies and gentlemen, today we're going to be discussing histograms. So a histogram is a brand new plot. Does anyone remember what a histogram looks like? So a histogram, does it look like that that's on the screen?
Oh, no.
What do we call that? Yeah, that's a dot plot. A histogram looks like a bar graph.
Oh, is it?
What's that?
Sideways.
No, the bar graphs that are sideways are still called bar graphs. A histogram is a very specific type of bar graph. It has a lot more requirements because each bar, the area of each bar has a meaning. So one of the requirements in your notes page has an example of a histogram. So take a look on there. A bar graph, the bars don't touch, whereas in a histogram, the bars are touching. And in order to create a histogram, you have to start with collecting data. So this particular student collected data and just asked, how much change do you have in your pocket? And two students had no money in their pocket, so that represents the two dots above zero. Two students had a nickel in their, one student had a nickel in their pocket. Four students had a dime, and so on. And so what we're going to do is create what's called a histogram about that. Can anyone tell me how many students were surveyed? Logan? 25. How'd you get that?
Counting them.
Okay. Did anyone else get 25? Great. So a histogram is helpful when you have a large amount of data because dot plots have one dot for every single person. It doesn't really make sense to create a dot plot when we're creating a graph of, let's say, everyone in the school. However, if we are creating a graph of everyone in the school, we can then use what's called a histogram. This is an example of a histogram right here. And what it does is it creates a bar where the height represents how many students meet that particular requirement. Now, the thing that is tricky about histograms is that the bars touch. And so what that means is this very first bar, you can see that 3 students meet the requirement of that first bar because it's 3 units high. If you count on the horizontal, or sorry, the vertical axis, 1, 2, 3. So 3 students meet that requirement. But do you notice how this bar touches the 10? Do you guys see that? So you have to know how to interpret it. What this means is 3 students have between 0 and up to, but not including, 10 cents. Okay? So this represents the 3 students that have 0 to 9 cents. Okay? So that bar goes up in 2, but doesn't include the 10. Now this bar, which is 4 high, which I'll do in a different color, this includes those that have 10 cents, 11, 12, all the way to 19. So this is 10 through 19 cents. And then in the next bar, you include those that have 20 or more. So the border is for those that include the next bar. Okay, so this bar is for those that have between 20 and 29 cents. Right? So the fact that this bar right down here is missing means what? Yeah, so no one brought out, let's say, 35 cents or 34 or anything, so nobody had 30 to 39 cents. Now, looking at a histogram, we can count how many students there are still, just like you guys counted the dots before, because this is 4, this is 6. Here we have a bunch of 3s, so 3, 3, 4, and then 2. And if we add those up, because it's based on the other data, we should still get 25. And again, we can also do large amounts of data. Think if on the vertical axis we were counting by tens or by hundreds. This could be 0 students, 200 students, 400 students, 600 students. So we can get as big as we want, whereas the dot plots, truly each dot was a person. So that is quite limited. So looking at the information here about the plots, the horizontal axis has to be numerical and in order. Interval widths have to be the same. So in other words, this has to go up, bless you, by a consistent amount, as does that. The left side always has to be the number of data points, whether it be number of students, number of cows, number of houses. This also can be called frequency. Frequency is another way of saying number of, all right? And we did talk about frequency the very first day that we discussed this. So when you go about creating a histogram, you have to decide how wide you want your bars to be. So we could have our bars represent 5 cents. So notice how many bars get generated if we did 5 cents. Or we could have the bars represent 20 cents. I want you to note what this graph looks like and this graph looks like compared to our original one. What do you guys think comparing these two graphs with the one that you have on your paper? Or if you flip over yours, you can see all 3 all together on the back side of your notes page. Which do you think is the most effective of the 3 graphs? Isabel? Going up by tens. And why would you say that?
Because it's more accurate how much.
Okay. So they all have the same data. Why do you think the first one looks the most accurate?
It's like showing but you can see, like, instead of the last one that's like, you can't see any between 0 and 20, this one you can see 0 and 5 cents, 10 cents.
Right, so this one you say doesn't have enough information. This one, you might argue, has too much information. It looks almost like, a heartbeat chart. There's just way too much going on here. It's too busy. Whereas, if we look at that one, might have just enough information. So while it all shows the same data, this is just like a big block of nothing. And this is just too much to process almost. This is almost like telling me exactly how much everybody has, which is too much. So what the general rule is, and what you guys are going to want to highlight or outline on your paper, is that you want to have less than 10, but more than 5 bars. Okay. So the sweet spot is between 5 and 10 bars. That is what tends to be the most effective with histograms. So with this one, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we also would have 10, 11, 12, 13, 14, 15, 16 potential bars. Whereas this one, there was only 4 bars. Okay. So too many, too few. Whereas the one that the original saw had the correct amount of bars. So that would be an example of something that shows the right amount of information to show the story of the graph. So we're going for between 5 and 10 bars. Okay. So the way you do this is if you have the data displayed in a dot plot. You don't have to. But you take the data and you decide how to split it up. So if we decide to go up by tens, we know that we're going to take the first amount of data. This represents the number of people that have between 0 and not yet 10 cents in their pocket. So 1, 2, 3 people had either 0 or 5 cents in their pocket, but not yet 10. So those people went in the first bar. The second bar, they also have been called bins, depending on the textbook you're using, had 10 cents or more, but not yet 20. Then we have 20 cents, but not yet 30. This bar is missing 30 cents, but not yet 40. 40 cents, but not yet 50. 50 cents, but not yet 60. 60, but not yet 70. 70, but not yet 80. And then we have nobody with 80 cents or more of change in their pocket. So you have to determine how many are in each category, and then that's how high we make the bar. So actually, what I'd like us to do is create a histogram right now. And I'm going to give us some sample data to work with. I'm going to try and see if you guys have some room. Yeah, grab a sheet of paper. All right, so go ahead and write down the data. Let's say this is number of persons living in the house. That'd be a good start to order the data. Another thing you could do to organize the data is you could put it in a dot plot. So our minimum is 1 person living in a house. Maximum is 9. I might have to add a few data points here. I'm going to add them in blue in case you've already started. Add some larger families into the mix.
Is that 4 and 9? Is that 49?
Good question. 4 and 9. I'm going to create a little dot plot. Counting 1, 2, 3, 4, 6s.
Yeah.
Then you have to determine how wide to make your bins, or how wide to make your bars on your histogram. So we're going to write number of people in household on the bottom. And number of people in household would go there, and this is houses. Number of houses there. So what do we want to number by? So we have the number of bars is between 5 and 10.
5 and 10 maybe.
Yeah, so when we create our histogram, we want between 5 and 10 bars. Davian?
We get sectional by 2.
Okay.
0 to 2, 3, 4.
So we'll go up by 2s. So the first bar represents the number of people that have 0 or 1, but do I include 2 people in the first bar? No, because 2 people will go in the second bar. Okay. So this is my first bar, just 1 high, because that represents the number of people that have 0 or 1. Then the next bar represents the number of houses that have 2 or 3, okay? Because if you're on the number, it goes in the next one. So 2 or 3, there are 3 houses. Then we go 4 or 5. That's going to be 5 high. The numbers on top so it's clear since I'm not using a grid right now. So 6 and 8, 6 to 8 represents those that have 6 or 7. Because if you're 8, you go in the next bar. So 6 or 7, that's going to be 6 households. Eight to 10, that's 8. 8 to almost 10, so that's 4. And then 10 or 11, I have 1. And 12 to 14, I have 1. So the key is, if you're on the border, it goes in the next one. That, to me, is the tricky part, and also determining how many bars. You want to have between 5 and 10. We have 1, 2, 3, 4, 5, 6, 7 bars, which is between 5 and 10. So again, if you're on the border, it goes in the next one, right? And one thing I want to show you about the assignment, and let me give it to you so you can actually take a look at it. Yeah, I have it there, yeah. So, one thing I wanted to point out to you is for number 2, you do have to complete a graph. And